Hi guys, here's 2.4 part 2. This is going to be all things factoring by grouping. So I'm going to show you two different ways that we incorporate the factoring method of factoring by grouping. The first one is when we're faced with a term or a polynomial that's a third degree, so meaning it starts with the 3 as its highest exponent, but its last term is a constant, meaning it's got no variable. So when I'm first looking at this, I always say, can I factor out a monomial? Is there a greatest common factor? My first term's a 1, so that's the highest number I could factor out, which means we don't factor out 1. And then my x or my variables, I have 1 in every term except my last term. So if I don't have it in my last term, I can't factor it out at all. So there's no monomial that can be factored out. So then I just start factoring by grouping. So the way that I do that is I group my first two terms and my last two terms together. So I'd rewrite this as x cubed minus 3x squared. Sorry, sometimes when I write in pen, I start writing a little weird. That's a 3. And negative 6x plus 48. Sorry. Now I have to figure out what's my greatest common factor of this group and what's my greatest common factor of this group. Okay, so I start looking, do I have do I have a number I can take out? Again, 1's my highest, or 1's my lowest, 3's my highest. I can't take something out that's not there, so I cannot take out any numbers. So then let's start looking at variables. X cubed, x squared. The most I could take out is an x squared. So I take that out because that's the least amount that I have. Divide x cubed by x squared. That gives me x. Divide negative 3x by x squared. That gives me negative 3. Okay, so this is what's left over. I move on to the second group and say, what can I take out of that? So again, I have a variable and then I don't. So there's no variable I can take out. I start looking at my numbers. Negative 16 and 48. You can play around with this for a while. I know since they're both even, I can take out a 2. I also know 48 is divisible by 4, so I could take out a 4. But then I keep pushing it, and I play with the factors of 48, and I find that 48 is actually divisible by 16. So I can take out an entire 16. But the end goal is that what's left over inside of here is the same as what's over here. So knowing that, I'm going to take out a negative 16, not just a 16. Okay, so take out negative 16. Again, that's like dividing by negative 16. That gives me positive x. Negative 16 divided by negative 16 is 1, positive 1 specifically, and then x is left over. Now I'm dividing 48 by negative 16. That gives me negative 3. Again, positive divided by negative becomes negative. But the ending goal, again, was I wanted what is inside of here to match what's inside of here. They match, so I'm good. If they don't match, you did something wrong. Now what we do is we take what's factored out of both of these, and we put them together into a binomial. Okay, again, we put them together into a binomial. Then my matching binomial comes down with that. So first two terms go inside this one. My matching one comes here. We always reevaluate. Can I factor more? Can I keep going? The answer to this binomial is no. To this is yes, I can keep factoring. This is a difference of squares. Square root of 16 is 4. So it becomes x plus 4 times x minus 4. And then we bring down the x minus 3 as well. Okay. This is again a different one. Factoring with difference of squares right here should be something you're comfortable with from chapter 1. If you're not, go back and watch that video. This would be your final answer. So we take that to say, what are my solutions then? X plus 4 gets set equal to 0, x minus 4, and x minus 3. We solve for x. This is x equals negative 4. x equals positive 4, and x equals positive 3. So all of my solutions are negative 4, 4, and positive 3. Some people will say, do I have to do this step if by looking at these I can say I'm going to take the opposite, the opposite, the opposite, and put them up here? Absolutely. If you can figure that out, don't do this step, jump to here. If you need this step, go ahead and keep it. But this is the answer to the factoring by grouping for this question, by finding the solutions. So now down here is my second example. You can see right away that I don't have 3 terms, or I don't have 4 terms, or I only have 3. But the reason I have to use factor by grouping for this one is because when we factor out trinomials, we always have a leading coefficient of 1. When we don't know how to do it. So this is kind of a spin on factoring by grouping. There's some additional steps in here that we need to talk about. If it's only 3 terms, what we do first is we take our leading coefficient and multiply it by our constant. So 3 times negative 8 gives me negative 24. Now I need to find factors of 24 that add up to positive 10. So factors of 24 would be 6 and 4, 2 and 12, obviously 1 and 24, 3 and 8. That should be all of them. So now which of them add up to positive 10, but also multiply to negative 24? 6 and 4 would work, but they don't multiply to negative 24 because they both need to be positive. So these are out. 1 and 24 is definitely not going to work. 3 and 8 will never add up to positive 10. So those are out. Which one of these needs to be negative? That is going to be the 2. Negative 2 times 12, negative 24. Negative 2 plus 12, positive 10. So what we do is we take these 2 terms and we use them to rewrite our original equation or function that we started with. Specifically, we're going to rewrite this 10x term by using negative 2x and positive 12. So this one gets a little, it's more steps for sure, but I have to be very careful in the way that I order these 2 variables and these 2 x's. I have to put them in order so that the term they're next to when I do factor by grouping is terms that have like factors. So 3 and 2, they don't have like factors, but 3 and 12 do. 8 and 2 have like factors, so do 8 and 12. But since 2 is the only one that has factors with 8, it doesn't have factor 3, I'm going to put 2 next to the 8. So I rewrite this with my ending and my beginning term already there and down. What goes in the middle here is these 2, like I said. The 12 is going to go by the 3 because that's where it has more alike factors, and the 2 will go by the 8 because that's where it has more alike factors. So now you can see this is more comparable to factor by grouping. We have 4 terms, so now we will go ahead and group our 2 front and our 2 back terms together. If I were you right now, I would stop and pause this video and I would say, all right, I need to figure this out. I need to do this one on my own, and I would try factoring by grouping on your own. Play the video and see if it follows along. So again, I would pause the video right here if you're trying this along with me. If you paused it and you're coming back, here's the solution. So between 3 and 12, they have the common factor of 3. Between x squared and x, they have the common factor of x. So let's figure out what is left over. 3x squared divided by 3x. Oh, sorry, you can't quite. Nope. There we go. Would be just x. Okay, now 12x divided by 3x is going to be positive 4. Okay, and then in this term, we have to start thinking in terms of I need this to be x plus 4 left over. So that means I'm going to have positives inside. So first thing, Neither of them, or one has an x, one doesn't, so I can't pull out an x. We have a 2 as a common factor because 2 also goes into 8. So I'm pulling out a 2, but not just any 2. I'm going to specifically pull out a negative 2. Divide each term by negative 2. What's left here is x. What's left here is positive 4. So again, I have these two binomials that are matching. So what happens is I take this first part and this first part, and we put it together in a binomial. Okay, it doesn't matter if this is in front or back, either way. And then we take our matching binomial and we bring it down here. Again, these are set equal to 0. In order to find my factors, I have to, or my solutions, take each of these separately, set them equal to 0, and solve. So this would be 3x equals positive 2, divide by 3. I'm getting that x equals 2/3, and that x equals negative 4. So my solutions would be negative 4 and positive 2/3. Okay. So again, this is factoring by grouping in two different ways. It all depends on what you start with. Okay. A little bit longer of a process, no doubt, but important that you learn how the process works. So if you do have any questions, please let me know. If not, go ahead and try that corresponding homework that goes along with this. Thank you.